Good day, class. Welcome to another edition of Sparks University Secondary School online chemistry class. I'm Solomon, your online chemistry teacher. In our last lecture, we're discussing an important derivative of chlorine, which is the chloride of metal. And this is the assignment of the last lecture, and here are the solutions to the assignment. Today will be our concluding lecture for the halogen family. Now, we're going to discuss bromine and iodine in our lecture today. Now, under bromine and iodine, we're going to talk about their occurrence in nature, the laboratory preparation, some of their properties, and tests for bromine and iodine in the lab. And after that, we're going to discuss the uses of silver halide in photography. Bromine and iodine were discovered by Curtius and Ballard, respectively. Now, Curtius discovered bromine in 1812, while Ballard discovered iodine in 1826. Now, just like chlorine, they occur naturally in their combined state, but iodine can occur freely in minute concentration in its free state. Now, to bromine. Bromine exists in its combined state as bromide of metals like the potassium bromide and the sodium bromide and magnesium bromide, which occur in sea salt and in salt deposits. But these bromide are not as abundant as chloride. But iodine occur in minute concentration in seawater, and they can also be found in organic compound in some seaweed and as a deposit of sodium and calcium triiodate 5. And to their preparation. Bromine and iodine are prepared industrially by the displacement reaction with chlorine from their salt after being obtained from the salty sea and then acidified. Now, we're not going to talk about the displacement reaction here, but we're still going to talk about it when we discuss the laboratory preparation, the second method of preparing bromine and iodine in the lab. Now, to the first method of preparing bromine and iodine in the lab, which is the action of the bromide salt or iodide salt on concentrated tetrasulfate 6 acid and an oxidizing agent. Now, this method is also the same method we use in the preparation of chlorine gas in the laboratory. Now, this you can see, for example, this potassium bromide reacting with the tetrasulfate 6 acid, the concentrated tetrasulfate 6 acid, and an oxidizing agent, which is manganese 4 oxide. And this whole reaction liberates the bromine gas. Same also for iodine gas. Now, please take note that in this reaction, the bromide ion, the bromide ion is being displaced by the sulfate ion from the hydrogen tetrasulfate 6 to form the potassium tetrasulfate 6 and hydrogen bromide. Now, it's that hydrogen bromide that will react with the oxidizing agent, this MnO2, to liberate the bromine gas. And the same thing, the same principle also follow for the liberation of iodine gas from potassium iodide. Now, to the second method of the laboratory preparation of bromine and iodine. Bromine and iodine can be prepared by the displacement reaction with chlorine from their aqueous solution of their salt. Now, this chlorine gas displacing the bromine gas from potassium bromide and forming the potassium chloride and liberating the chlorine gas. Also, the same thing for iodine gas. Chlorine reacting with potassium iodide, displacing the iodine gas and forming the potassium chloride. Now, this is just the ionic equation of the reaction, of both reactions. Now, to their properties. Bromine and iodine are non-metals and they form poisonous vapor, and they also exist as diatomic molecule. Now, they combine with hydrogen to form a very soluble gas. That means bromine combine with hydrogen to form the hydrogen bromide gas, while iodine combine with hydrogen to form the hydrogen iodide gas. Now, these gases are soluble in water to yield acidic solution. Now, hydrogen bromide gas dissolve in water to form the hydrobromic acid, while hydrogen iodide gas dissolve in water to form the hydroiodide acid. Now, bromine and iodine combine with metal and non-metal to form the bromide and the iodide of the metal and the non-metal respectively. Now to the test for bromine and iodine. Now when we talk about test for bromine and iodine in the lab, we talk about the test for the bromide ion and also the iodide ion. And we can use two reagents in the lab to test for bromine and iodine, which is the first one is the tetrasulfate 6 acid and the second one is silver triazole solution. Now with tetrasulfate 6 acid, heat some unknown solid with a little concentrated tetrasulfate 6 acid. Now if bromide ion is present in the solid, white fumes of hydrogen bromide will be formed and a reddish film of bromine vapor also will be formed. But if an iodide ion is present in the unknown solid, purple fumes of iodine gas will be evolved. Now when we use silver triazole 5, add silver triazole 5 to a solution containing the unknown solution. If bromide ion is present in the solution, a pale yellow precipitate of silver bromide will be formed. But if iodide ion is present in the solution, a yellow precipitate of silver iodide will be formed. And to the uses of silver halide in photography. Now silver halide changes color when they are exposed to sunlight. Now when I talk about silver halide, I talk about the silver chloride, the silver bromide and the silver iodide. Now silver chloride changes from white to purple grey, while silver bromide changes from cream to greenish to green yellow color, while silver iodide is not affected on exposure to sunlight. Now to their uses. Now the changes in color when silver chloride and silver bromide are exposed when exposed to sunlight are chemical reaction in which the silver chloride and the silver bromide are converted to the metallic silver and to the respective halogen. Now this silver chloride when exposed to sunlight form the metallic silver and liberate the chlorine gas. And also the silver bromide when exposed to sunlight form the silver metal and liberate the bromine gas. Now this change in silver bromide is due to the effect of sunlight, as I have said before, and this property of change in the color of silver bromide is we make use of it in black and white photography. Now photographic plates and films of black and white camera contain silver bromide, now which decompose on exposure to light. When we are developing the photograph after taking the image of an object, the film is treated with sodium thiosulfate solution. Now the sodium thiosulfate solution is used to remove the excess silver bromide present after we have exposed it to sunlight. Now after that, we are left with the silver metal being formed on the film, and this is formed as an opaque shadow, which is also the photograph of the object we took. Now we've come to the end of discussion of our class today, and we've come to the end of our discussion of the halogen family. Thank you for watching this edition of Class University Secondary School online chemistry class. Hope to meet you again in the next edition of Class University Secondary School class. Thank you.